In this video, we're going to look at the congruent supplements and complements theorems and how to use those in triangle proofs. So for the first one here, we're given some different information. So we're given congruent segments, congruent angles, and then this line or segment BPD. That part right here isn't really relevant. So, I mean, you can see that just by looking at the picture, so you don't really need to worry about writing that one down. But if we look at what triangles we're trying to prove are congruent, that's going to be kind of our first step here. So then we can start marking things. So we have ABP, so triangle ABP. We're trying to prove that that's congruent to CBP. So right away I'm seeing a shared side right when the colors overlap. And then let's go ahead and mark those other pieces that they gave us. So AP and CP. And then I have two angles, X and Y, that are congruent that are not in the triangle. So this is kind of a red flag that right now I am not going to be using those as part of my congruence theorem. But the reason why we're given those is so that we can then find triangles inside of the, or angles inside of the triangles that are congruent. So these are not in triangles, not in the triangles. So that is kind of my indication to look for supplementary or complementary angles. So let's go ahead and start with just writing out our given. So AP is congruent to CP. And then I also had angle X is congruent to angle Y. So looking at this, I have a set of sides. I see the reflexive property, so we can go ahead and write that down. So I can say BP is congruent to BP by the reflexive. And then I want to try to get these angles right here, because when I look at those, they're touching the angles that are congruent, but these angles are the angles in the triangle. So what I think about is the fact that angle X, and let's just call this angle 1 and angle 2. Angle X and angle 1 are supplementary because they form a straight line, and then same thing with Y and 2. So what I can do, that's not really off of this, but I'm going to use it. So I'm going to kind of just write it underneath so I'm out of space. But I'm going to say angle 1 is supplementary to angle X, and angle 2 is supplementary to angle Y. And my reason for that is because those angles form a straight line. So I can say angles that form a line are supplementary. Or two angles that form a line are supplementary. So then using these two together, I can say, since I have X and Y here and right here, I can say 1 and 2 have to be congruent, because if you have angles that are supplementary to congruent angles, those two angles have to be congruent. That's that congruent supplements theorem. So that will allow me to mark these inside angles. So this is the congruent supplements theorem. And then from there, I can see now in my picture that I have side angle side. So looking at my proof, I have one set of side, I have the set of angles, and I have the other set of sides. So now I can take these three things, so the side, angle, and then this other side, and I can say that the triangles are congruent. By side angle side. So that's kind of how we can use the congruent supplements theorem. Now, keep in mind, I don't have a connecting piece between this statement here and this one, the supplementary and the given, because those aren't, I didn't use the given to imply this. This came from the diagram, the supplementary, so that's why it's not attached. Really, if I had more space, I'd put it up top with it, but not attaching it is kind of the same thing. So that's the idea here, is just looking for those supplementary and complementary angles so that we can use the congruence theorems with those. So let's try another one. In this picture here, we have lots of information given to us. So we have MS is the perpendicular bisector of LP. We have RM is congruent to QM, and we have A and B are congruent. Let's look at what triangles we're trying to prove first, get those highlighted. So RLM, so this triangle right here, and QPM. So right away, I'm gonna get my givens down. So MS is the perpendicular bisector of LP. That's given. RM is congruent to QM. And then I have angle A is congruent to angle B. And then let's get these labeled in our picture. So if I have a perpendicular bisector, there's two things I can say. I can say I have right angles, and I can also say that I have congruent segments, two congruent segments. So these two segments have to be congruent. And then I have RM and QM, and then I have angle A and angle B. So first thing is I should write down what I just said about the perpendicular bisector. I marked my picture, but it's always good to get that written down right away. So from that, there was really two conclusions I could make. So one of them being that LM is congruent to MP because a perpendicular bisector implies two congruent segments. So that was one thing I wrote. The other conclusion here is that I said I had right angles. So I can say that I have S, so angle SML and angle SMP are right angles because a perpendicular bisector implies right angles. And then, so far that's everything that I've labeled. So I have everything that I marked in my proof. So when I look at this, I'm seeing I have a set of sides and I have another set of sides, and I don't have these angles here, but I have the whole angles and I have these parts that are congruent. So you have really two options to get those angles inside of the triangle. You could do the angle subtraction. You could say that these right angles are equal, and then you could subtract off two congruent parts. Or what we can do is we can say that these angles with the stars, so let's actually put numbers in there. So let's call this angle 1 and angle 2. I can say that I have complementary angles and then use the congruence complements theorem. So I'm going to do it that way. Just to show you how that's done, but you could also do angle subtraction with this. So the red flag being the two angles they gave me were not in the triangle, so we could even add that up here. When they gave me this, these were not in the triangles, so that was kind of my red flag that I'm looking for the congruent supplements or complements theorem to get the angles in the triangle. So what I need to do now is I need to say that I have complementary angles. So I'm going to go ahead and underneath the right angles, since I have right angles, I can now say that angle 1 and angle A. So angle 1 is complementary to angle A, and angle 2 is complementary to angle B. And my reason for that, and notice this is coming from the right angles because I had to have the right angles for that. My reason for this is because I have two angles that form a right angle are complementary. And then from here, well, now I have, if I look at this statement right here with the congruent angles, if I know A and B are congruent, well, that's going to force 1 and 2 to be congruent. Let me move this down so you can see this. So 1 and 2 are congruent because if I have two angles that are complementary to congruent angles, then they have to be congruent. So this is the congruent complements theorem. So then from here, if I go back up, I can mark these as congruent now. And I can say that these triangles are congruent by side angle side. So if you look in my proof for side angle sides, so my side, I have a set of sides right here. So that gets me this. I have my set of angles, and then I have my other sets of sides. So my other sets of sides are right here. So that gets me that. So now that I have all of these in my proof, off of these three things, so I can go off of here, here, and this set of sides, I can say that the two triangles are congruent. So I can say triangle RLM is congruent to triangle QPM. So using my side, angle, side, those are congruent. And you could put this below, but I'm just running out of space, so that's why I just did it off to the side. So we have all of our three, remember there's always three things that lead into those congruent triangles. So that's using the different complements theorem. So save the check your understanding page for us to do in class tomorrow. So you don't need to do that tonight. You're just going to do that tomorrow in class.